In some cases, you will want to provide constant values that can be used throughout your code. For example, you may decide to declare a constant for p. You should not allow this value to be changed because it will change the underlying logic in your code. So this means that you should mark the variable as being constant. So when you do this, the compiler will check the use of the variable, and if it is used in the code that changes the value of the variable, the compiler will give you an error. So let's create a constant variable here, constant double p here, 3.14 and 15, and then double radius. Double radius equals 5.0 here, assigned to 5.0, and double circumference. Runs 2 multiplied by p and radius here. So in this case, the symbol p here is declared as being constant. So it cannot change. If you subsequently decide to change the constant, the compiler will give you an error. So once you declare the constant, you can be assured that the compiler will make sure it remains to. So you can assign the constant with expression as well. So for example, let's include cmat, include okay, cmat here, and then let's make a constant double of 2 equals constant double square root of 2 equals std sqrt and 2 here. So now I want to change, for example, as you can see, this is the constant, we cannot change it, but let's try if we can change our constant value. So let's may assign p to, for example, 99. As you can see, we got an error. Cannot assign to variable p with the const qualified type const double. So in order to work this code, we can, as you can see here, const, we have to delete the const, and now we can assign p on some variable here. So let's run our code and see what error we will get. Error: assignment of read-only variable p. As you can see here, we got an error in 12 line p99 here. So now, as I can show you, we can delete this, clear this, and let's delete this line of code as well. So in this code, as you can see, we got a constant. We created a new double constant square root of 2, and we used this cmat library, which you will learn more in next lectures. So you can also use constant to declare a constant that will be used as a constant expression. For example, you can declare an array using the square bracket syntax. For example, let's create an array here. Okay, integer values 5. This is an array. So this declares an array of 5 integers, and the stack and the items are accessed through the values array variable. So the 5 is here is constant expression. So when you declare an array on the stack, you have to provide the compiler with a constant expression so it knows how much memory to allocate, and this means that the size of the array must be known at compile time. So you can allocate an array with a size known only at runtime, but this requires dynamic memory allocation, which we will explain in next lecture. Next sections, in section named working with memory, pointers, and arrays. So in C++, you can declare the constant like this too. For example, constant integer size equals 5, integer my new values, and pass this as parameter size here. So we pass this size And as you can see, our size equals to 5. So this and this line of code is the same, just different variable names. So elsewhere in your code, when you access the values array, you can use the size constant to make sure that you don't access items past end of the day. So since the size variable is declared in just one place, we need to change the size of the array at a later stage. So you have just one place to make this change. Also, the const keyword here can also be used on pointers and references, which you will learn in the next sections, and also on the objects. Often you will see it used on the parameters to functions. So this is used to get the compiler to help ensure that pointers, references, and objects are used properly as you intended.